I'm going to show you two ways of doing this question. One, the quick way, relatively and simple, and two, the way that I actually did it, which is unnecessarily complicated, but it's just an alternative look at the question. All right, method one is to draw. Well, actually, let me just say, first of all, that whenever you have a question like this, you're going to need to use the circle somehow, the radius of the circle. So it's going to make sense to connect a line up like that. Yeah, that's going to be like the first thing that you do. And in this case, for this solution that I'm going to show you, I'm going to then create a right angled triangle. Now I know that this length is 10, and I'm going to call the length of the square x, which means that this will be x over 2 because of the symmetry of the problem. This is x over 2. So now I just need to think about what this length will be, and I'll be sorted. Well, I've got x. Okay, so it's this one that I'm worried about. But actually, because I've split it down the middle, then actually I have a 45-degree angle here. And this is a right angle, so this will also be 45 degrees. And I've constructed an isosceles triangle. This length is the same as this length. So in fact, this smaller length is also x over 2. And if I add the two together, I get the whole triangle. It's actually going to be 3x over 2. So now I can use Pythagoras' theorem. 3x over 2 squared plus x over 2 squared is going to equal 10 squared, or 100. 9x squared over 4 plus x squared over 4 is going to equal 100. That's going to be 10x squared over 4 is equal to 100. I can divide both through by 10 times by 4, and x squared is going to be 40. And in fact, that is the area of the square. And we're finished. On to method 2. I'm not recommending you do this, but it's just an alternative way of solving the problem. So again, this is what I did. I thought, right, so I'm going to connect it up to this corner. And then I didn't spot this right angle triangle, but I did, however, spot this triangle here. So now I have that this length is 10, and this one is going to be x, that's the length of my square. So what about this one here? Well, I did spot that it was, again, for the symmetry now, I've got an isosceles triangle here where this is 45 and this is 45. So if this length is x, then this one is going to be x over root 2. So now I have my three lengths to my triangle. But what to do? How can I find x? Well, I need to think carefully about the angles. Now, this angle is not obvious at all. This one is not. But I've just said that that is 45 and this is 90. So actually, I do have an angle here of 135. And I then use the cosine rule to relate the angles, the angle 135 with the x. So it's going to be 10 squared is equal to x squared plus x over root 2 squared minus 2 times x over root 2 cos 135. Okay, now that is one to think about a little bit. Cos 135. So here's 90, and cos 135, well, it's going to be 45 away from 90. And we know that cos, sorry, this is not drawn accurately or anything, cos 45 is 1 over root 2. So by the symmetry of the cosine curve, it's going to be minus 1 over root 2. Therefore, 100 is equal to x squared plus x squared over 2 minus 2x x over root 2 times minus 1 over root 2. So this is great because the root 2, that will become 2, that will cancel with that, and then the minuses will also cancel. And I'm going to get 100 is equal to 2x squared. This is going to be 5x squared over 2. And then I'm again going to rearrange this. X squared, I'm going to get 200 divided by 5. I'm going to get 40.